Hello friends, welcome to our channel. In today's session, let us have a discussion on window to viewport transformation. So, before going to that, we need to know what is the window and what is a viewport. So, if there is a selected image, for example, this is an image, and we need to capture this image so that we can. So, the portion to be selected is called window. So that means the portion or the space in which the object should be displayed is called window. So that means simply we can say a window is what to be displayed. So which portion should be displayed. And similarly, a viewport is nothing but the place where we are displaying the object of a window. That means so this is the viewport. That means we are just displaying this portion. So this is called the viewport. That means in the window, the object where to be displayed on the device, in which device and where to be displayed is called viewport. That means simply we can say where viewport is where to be displayed. Simply a window is what to be displayed, viewport is where to be displayed. So obviously for this window there will be boundary values that we call it as x and y boundaries. So for any two-dimensional plane, we can have an x boundary and a y boundary that we will represent as xw minimum and xw maximum towards x-axis, and yw minimum, yw maximum. So here this w represents the window, the boundary of a window. So here a window is a rectangular portion, so a window can be any shape, but here we are considering as a rectangle or a square, whatever it may be. So a window is what to be displayed, what portion of the object should be displayed, and viewport is where this portion should be displayed. That means on a device coordinates. So this can be called as a window coordinates. And the boundaries of a viewport we will call as device coordinates. We can call them as device coordinates or viewport coordinates, whatever it may be. Similarly, for this viewport also we will be having some coordinates that we call it as that can be represented as xv minimum, xv maximum, yv minimum, yv maximum. So these are the boundaries of a viewport and these are the boundaries of a window. So these can be called as window coordinates. This can be called as device coordinates, or simply we can call it as viewport coordinates. So here W represents the window, V represents the viewport. And now the question is, if we select a particular pixel or a point in a window, so what is the particular point in the viewport? So we have to find the same point in the viewport. So obviously the boundaries will be different for window and this viewport. So obviously the selected point will be changed in the viewport. That means the scaling transformation will be done. So the image may be maximized or minimized. So scaling transformation will be done, and we need to find the viewport coordinate. So here we will having xw, yw, that is window coordinates, and for this particular window coordinate xw and yw, we need to find the corresponding viewport coordinates, that is xv comma yv. So the window is if we consider any point in the window xw yw, we need to find the same corresponding viewport coordinate. So obviously both are different because it is having its own boundaries and it is having its own boundaries. Now in this session we will have a simple problem and a simple example for this finding of viewport coordinate from window coordinate. So this concept we call it as window to viewport transformation. Window to viewport transformation, right? Let us consider 2 points. So this is a window. So towards x-axis, that is xw minimum. This is xw maximum. This is yw minimum. This is yw maximum. Similarly, let us consider a viewport also. So this is a window. This is a window. So this is a viewport. Let us consider a viewport also. So let us consider this is a viewport. So this is xv minimum, xv maximum, yv minimum, yv maximum. So these are the boundaries for a viewport. Now we are knowing some. So if the window is having a circle here, and this circle will be displayed on the viewport in a small size, so automatically the size may differ because based upon the boundaries the object will be displayed. So within these boundaries the object is displayed here, and within these boundaries the object may be minimized or maximized. So if there is a triangle, a very big triangle, so the same triangle will be displayed at the same position, relative position, but based upon these boundaries. That means here we can display a small triangle. That means, so here the transformation is going to be done, that is a scaling transformation. So as we have discussed in the previous sessions, the scaling transformation is nothing but a changing the size of an object. Here also the size will vary based upon the boundaries, the size may vary. But the important point is the position will not change. The relative position will not change for both the window and viewport. The only change is the size of an object. So based upon the relative position, we need to find the viewport coordinates for the given window port coordinates. So window coordinates. Let us consider a point. This is a point, that is xw comma yw. Xw comma yw, and we need to find the corresponding viewport coordinates. So here also that is xv comma yv. So we had window coordinates and we need to find the viewport coordinates. For this purpose, so as we have discussed now itself, that the relative position is same. Relative position is same for both the window and viewport. So we can have a formula xw minus xw minimum, xw minus xw minimum, so this is the xw minimum, divided by total x-axis, that is xw maximum minus xw minimum, that is equal to, here also same, xv minus xv minimum, xv minus xv minimum by the complete difference, xv maximum minus xv minimum. So hope you understood this formula. So as the relative position is same, this is the important point. As the relative position is same, we are finding the same. So that means xw minus xw minimum, the distance from xw to x minimum by x difference, total difference. Similarly, x viewport to xv minimum by the complete distance. Similarly, the y coordinate also. So yw minus yw minimum by yw maximum minus yw minimum, that is equal to yv minus yv minimum by yv maximum minus yv minimum. So from this we can have this boundaries of window and boundaries of viewport. So we will have both the xw minimum, xw maximum, xw minimum, xv minimum, xv maximum, xv minimum, and similarly yw minimum, yw maximum, yw minimum, yw minimum, yv minimum, yv maximum, and yv minimum, and also we will have xw and yw. So the only point we need to find is the viewport coordinates, that is this xv, we don't know the point of xv. So we have to find the coordinates of viewport for the given xw and yw. So derive the formula so that xv is equal to so and so expression. Let us have that expression. So here write down xv minus xv minimum is equal to, so bring here xv maximum minus xv minimum into xw minus xw minimum by xw maximum minus xw minimum. So this can be written as xw minus xw minimum into, so just replacing xv maximum minus xv minimum by xw maximum minus xw minimum. So this term is nothing but a scaling factor. This term is nothing but a scaling factor. So this is can be written as Sx, scaling factor of with respect to x-axis. So this can be written as xw minus xw minimum into Sx. So this is and here xv is equal to, move the side, xv minimum plus xw minus xw minimum into Sx. So this is the formula for finding the viewport coordinate with respect to x-axis. So xv is equal to xv minimum plus xw minus xw minimum into scaling factor Sx. Similarly, so derive the formula for finding the viewport y coordinate. So same, apply the same procedure so that you can get the formula yv is equal to yv minimum plus yv minus yw minus yw minimum into S of y. So this is a formula for finding the y coordinate, viewport y coordinate. Here Sx and Sy are scaling factors. Hope you understood this formula. So that let us have an example. So finding the viewport coordinates for the any window coordinate, so that you can clearly understand. can write the formula here. XV is equal to XV minimum plus XW minus XW right. Let us have an example. So simply by solving an example you can easily identify that. So let us have a window with the boundaries. So here let us write here XW minimum, XW maximum. This is a y coordinate. YW minimum, YW maximum. So this is a window, and now let us write for Viewport. XV minimum, XV maximum, YV minimum, YV maximum. So this is a viewport and this is a window. Now let us have a problem that is this is a 20 and our maximum is 80, right? Next, so given XW minimum is equal to 20, XW maximum, so let us write YW minimum equal to YW maximum is equal to. So let us have an example, that is the boundaries, window boundaries, as XW minimum is equal to 20, XW maximum is equal to 80, and YW minimum is equal to 40, and YW maximum is equal to 80. Similarly, let us have XV minimum is equal to XV maximum, YV minimum, YV maximum. So let us consider the values 30, 60, 40, 60, and let us have the point XW, YW. So let us consider XW, YW is equal to 30, 80. 30, 80. So we need to find XV, YV. So directly apply the formula, or simply you can write the normal formula and without any direct formula. So let us write to find the XV. So as we know, the relative positions are same, so we have written a formula XV minus XV minus XV minimum. XV minimum is 30 by XV maximum 60 minus XV minimum 30 is equal to XW 30 minus XW minimum 20 by XW maximum 80 minus XW minimum 20. So XV minus 30 is equal to 10 by 80 minus 20, 60 into 30. So XV minus 30 is equal to So 5. So xv is equal to 35. So the x coordinate in a viewport is 35, but window coordinate x is 30, and here viewport x coordinate is 35. Now find out the y coordinate also. Yv minus yv minimum by yv maximum minus yv minimum 40 is equal to, similarly, yw is 80 minus yw minimum 20 by yw maximum, yw minimum is 40 here, right? 40, yw maximum minus yw minimum, so 80 minus 40. So yv is 80 minus yw minimum is 40, and divided by yw maximum minus yw minimum. So yv minus 40 is equal to, this is 1, so 60 minus 40 into 1. Yv is equal to 60 minus 40, 20. So 20 plus 40. So yv is equal to 60. So xv is 35, yv is 60. So this xv comma yv is 35 comma 60. So if we consider a point in a window as 30, 80, the corresponding viewport coordinate will be 35 comma 60. So just here the only one point is, so the same point here, so xv comma yv. So only one point is to be remembered, that is the main difference between window and a viewport. So window is what to be displayed and viewport is where to be displayed. So the position is same, the relative position of an object will be same. So according to the boundaries, the actual position may vary, but the relative position is same. So for that purpose, we are using the same formula in order to find the viewport coordinates. So we are having a window coordinate xw comma yw, and we need to find out the corresponding viewport coordinate xv comma yv. So as we know, the relative positions are same for window and viewport, so we are applying the same formula to find the xv comma yv. Hope you understood this problem. So this concept we call it as window to viewport transformation. So window to viewport transformation. So taking the window coordinate and finding out the corresponding viewport coordinates. Hope you understood this window to viewport transformation, and in the next session we will discuss about the clipping algorithms. Thank you.